Hi everybody, my name is Taylor Vasquez and my math model that I will be showing you guys is number towers. So what exactly are number towers? Number towers are used to practice inequality statements. They are also used to practice with numerals, number words, and patterns. It can also help their motor skills and their sensory skills because they are able to get hands-on with the blocks. As you can see in this picture, they're able to build them, they are able to sort them by color, and they're able to just like physically touch them. So having the act of building them or even just like touching them can help young students. And I also put cooperative learning because I feel this would work perfect in a cooperative learning lesson by having one student be the counter, the other being the recorder to write down the number, and then they could switch. That way each partner is getting a chance to get hands-on with the blocks. And then in Education 491, we're also talking about our SEL learning competencies, so I felt it was important to include that this would help with social awareness as well, because if they are working with a partner and they are getting like hands-on together, they're practicing their social awareness skills because they're going to need to know their social cues, how to communicate with one another, so I just thought it was important that I include that as well. Skills obtained through this practice, like I said, are the inequalities, so greater than, less than, equal to. It also helps students with counting. It also helps them with adding because they're having to add all of the blocks in each color, and they are also having to count them one by one, and then they're having to compare them to do greater than, to do less than, or equal to. So all of these mathematical skills kind of come together in this one math model. That way students are able to like better understand. How does this help students access math? This allows students to get hands-on with the material. They are able to build the blocks physically. They're able to count the blocks. They could even use their one finger to count method where they physically go 1, 2, 3. And then also like organizing by color. So as you can see in the corner, I have lavender blocks and I have pink blocks. That way you don't necessarily have to have students focus on the color, but it is just another way to practice an organizational skill. Also, students are manipulating their learning. So having students be the one to physically go and count the blocks and be the ones to move them around and take them apart, to basically do everything that under that umbrella. They're manipulating their learning, which helps them solve problems. They're going to be able to be more aware of everything. For our concrete skills, as I've been saying, this creates a hands-on experience. Students are able to act it out, and this is going to be their first step while learning a new concept. So this is kind of the introductory level of the math model for them. They just get to play around with the blocks, count them, get physical with it. I do have some examples here. So if we were practicing, since we are virtual, I can't physically have you guys messing around with blocks, but for example, here we have 1, 2, 3, 4 purple blocks, and then on this side we have 1, 2, 3 blocks. So students would be able to look at this. This is already organized for them, but they would count the numbers and they would say, okay, here's 4, here's 3. What inequality symbol should be going in the middle of them? Okay, 4 is greater than 3, so that inequality sentence makes sense, and then they would move on working on the next one. So here's another example. Here we have 1, 2 purple blocks, and on this side we have 1, 2, 3, 4, 5. So again, students would sit, count the blocks, and then they would be able to come together to find that 2 is less than 5. So for the activity that I have for you guys, if you guys are going to be my students, I have another slideshow. Here it is. So these are number tower rules. We are going to use this as if we are learning it in a virtual lesson, obviously, because we are virtual right now. So I have the rules. 1, read the top inequality. That way you know how many blocks to pull out for your inequality statement. 2, count your virtual blocks on the blue post-it, which you will see on the next slide. 3, determine which side has more. So once you pull your blocks together, kind of similar to something like this right here, you would then count, determine which side has more, and then the last step is to drag the proper inequality sign to the middle. So the first one we have up here is 4 and 6. So if I were a student doing this, I would go 1, 2, 3, 4. And then on this side I would do 1, 2, 3, 4, 5, and 6. Awesome. Now that I have counted out my blocks, I would go 1, 2, 3, 4. Okay, I have 4 just like it says on top. 1, 2, 3, 4, 5, 6. Awesome, just like it says on the bottom. And then I would determine which inequality goes in the middle. Is 4 greater than 6, is 4 less than 6, or is 4 equal to 6. So because I know my inequalities, I would drag this up so that way it says 4 is less than 6. So moving on to the second one, we would do 1, 2, 3, and this one we would do 1 and 2. So after looking at this, I would say, okay, I'm going to drag this one up because I know that 3 is greater than 2. I made more because if you were students in this case, you would be the one manipulating the blocks, these virtual blocks here. However, since we are not, I'm just going to drag the inequality up without dragging the blocks down, just so you can get a better idea. So 8, 10, okay, I would drag the blocks 1, 2, 3, 4, 5, 6, 7, 8, and then I would drag all 10 of these down here, so then I would still bring the less than symbol because 8 is less than 10. Another thing you can tell students, which I always like to tell my young ones, is kind of treat this like an alligator sign, and the alligator is always going to want to eat what is more, because why would someone ever want to eat what's less? So here the alligator wants 10 because 10 is bigger, so that's why it's facing that way. Just to kind of help them better understand inequalities if they are struggling in that area. For this one, it's 5, so I'd pull 5 blocks down, and then I'd pull 5 blocks down, and then I would pull the equal sign up, because 5 is equal to 5. And for our last one, I would pull 1, 2 down, I would pull 1, 2, 3, 4, and then after looking at it, I would be able to drag my less than sign up, and I would say 2 is less than 4. Okay, so that was our practice, our concrete practice. Now we're just going to dive into semi-concrete and understand what that is. Semi-concrete number towers are when students begin to create their own representations. This shows that students understand what they are learning, and also they're able to model with a computer if that is necessary. So for example, in this scenario, these were given to you, And then in semi-concrete, students would show they know by learning by creating their own examples. They would start to begin to create their own inequality statements and then use the numbers to help solve them. Moving on to abstract, which is the last step in understanding. This is the transition from practice to application. This is where students use actual numbers and statements. So that being said, they would not be using the blocks to count anymore. They would just see two numbers and say, okay, I see 4 and I see 8. I'm going to put the less than sign because 4 is less than 8. At this stage, students have the most knowledge, and students begin to understand the value of a number. They don't need the manipulative anymore to assist them in counting. They are just able to see the number and understand the value of each number and determine what number would be greater than, less than, or equal to. And lastly, I just have my resources that I use for my slide. Thank you so much for watching my presentation.